And so let us continue with our reactions in aqueous solution. Last time we ended our discussion sa 4 types of chemical reaction. So what are those again? We have the synthesis or combination reaction wherein we just combine 2 or more elements to form compound or compounds. And then, ang kabaliktaran niya, we call it the composition reaction wherein the compound will be broken down into its component na mga elements. And then, thirdly, we have the single replacement or single displacement method. I hope you have your index cards now about this one, that the activity series of metal, because the single replacement is dependent in this list. Kasi kailangan ang element na ipapalit mo will be more reactive than the original element na component ng iyong compound. And lastly, we have the double displacement, that is exchange partners. The cations and the anions of the two reactants will exchange and form new compound. So as a continuation, we'll have the precipitation reaction. Itong precipitation reaction is still under the double displacement reaction. It's just that this is specific because when two compounds react, they will form precipitate. So again, we call it precipitation reaction. Kapag after the reaction, there will be the formation of an insoluble product. Hindi na di-dissolve. Ang tawag natin dyan, precipitate. And then, most of our precipitation reactions usually involve ionic compounds. So again, pag ionic compounds class, we have the components na cation and anion. And again, ang precipitate na yan ay insoluble. It will be seen in the solution pero dili siya ma-dissolve. So, for example, we have here the lead 2 nitrite. Nakita ninyo aqueous siya, meaning this one is a liquid chemical. And then, ipapareact natin siya with potassium iodide or the Ki, which is another substance na in aqueous solution gihapon. So, liquid gihapon siya. So, we have here liquid plus liquid. But as you can see on the screen, sa reaction, it will produce the lead iodide and the 2 molecules of potassium nitrate. Na potassium nitrate is aqueous, meaning liquid siya. But take note, meron tayong S dyan, meaning solid. Si potassium iodide is a solid substance and that is an indication na naging precipitate siya dito. So again, this is an example of a precipitation reaction. Liquid plus liquid, pero ang product niya merong solid. So maging insoluble yung solid sa liquid part natin. Now, if you have observed, this type of reaction is an example of a metathesis reaction. Other name for metathesis is double replacement or double displacement reaction. We have here exchange parts or exchange partners between the compounds. So again, we have here lead nitrite reacting with potassium iodide, and then as you can see, nag-exchange sila sa kanilang partner. Lead is now partnered with iodide in the product. That is why you have there the lead iodide. And then the potassium will now be partnered with the nitrate. So you have there potassium nitrate. So exchange partners. So do not forget, pag sinabing precipitation reaction, double displacement, under pa rin siya sa double displacement reaction. So ang kaibahan lang from the other double displacement reaction, may solid ka na substance na form. So what happens here? You have there the lead nitrate and then the potassium iodide reacting with each other, if we are going to do a laboratory experiment, ito yung makikita natin class sa test tube. Ganito yung makikita natin sa test tube. Lead nitrate is colorless solution, while the potassium iodide is also a colorless solution. Pero pag pinaghalo natin sila, kung makikita niyo sa test tube on the screen, you will have a yellow solid substance, and that is the lead iodide. Okay, lead iodide yan siya. Yung other part ng liquid will be for the potassium nitrate. So, ganun yung magiging reaction niya. Merong precipitate na form. Again, solid ha, kapag ka precipitate, solid substance and insoluble. Hindi na di-dissolve. Kahit pa class, stir natin ito, i-shake natin, hindi talaga na di-dissolve yung precipitate na yan. So I hope that is clear. You can ask question or questions. Okay, so again, this is for the precipitation reaction. Now, how can we determine or predict whether a precipitate will be formed for a given reaction? So, ang answer, Ana, is solubility. Depende kasi siya sa solubility ng ating substance or ng ating chemicals, especially sa water. Because remember, our water is the universal solvent. And when you say solubility, it is defined as the maximum amount of our solute or our substance that will be dissolved in a given amount of solvent in a specific temperature. So kung kapag paglagay natin sa ating chemical and then na-dissolve siya sa water, for example, our solvent is water, then that chemical is called soluble. So kagaya ng ating sodium chloride, which is our table salt, ang ating asin, di ba? When we place that in water, we can see na the particles will be dissolved. So soluble siya. That is also true for our table sugar or our sucrose. Na if we place that in a glass of water, the particles will also be dissolved. So soluble sila. Pero kapag hindi na-dissolve or kapag merong na-dissolve, meron ding wala, ang tawag natin dyan, slightly soluble. Kung partial lang ang na-dissolve glass, hindi lahat. Pero kung paglagay mo, wala talagang any particle na na-dissolve, we call that insoluble sa chemistry. So that is how you predict whether you will have a precipitation reaction or not. So again, a substance is to be soluble if a fair amount of it visibly dissolves when added in water. So again, always ang ating solvent kay water. Most of our ionic compounds are capable of being dissolved sa tubig. But if not, merong mga substance na hindi na-dissolve, it can be slightly soluble, or kung wala talagang na-dissolve, we call that again insoluble. Now, our ionic compounds, those compounds with cations and anions as components, yung mga strong electrolytes natin, merong ibang soluble sa kanila, meron ding hindi. So, hindi talaga lahat ng ionic compounds natin or strong electrolytes ay soluble sa tubig. So, to guide you, we have here, class, solubility rules for common ionic compounds in water at 25 degrees Celsius. Ma'am, ang oil and water na belong sa precipitation. No, the combination of oil and water does not belong to the precipitation reaction. Bakit? Kasi pag sinabing precipitation reaction, there is the formation of a solid substance which is insoluble. Now, if you mix oil and water, remember, the two liquids will not just be mixed, pero walang formation ng solid substance. Walang formation ng precipitate. Wala kang solid na makikita dyan. So, ang ginagawa lang natin kapag pinagmimix natin si oil and si water, most likely, we will have two layers. So, hindi soluble yung tawag natin dyan. We use the term miscible. By the way, para ma-clarify natin. We use the term soluble if it is a mixture between a solid substance and a liquid. Okay? Solid and a liquid. Now, if the solid dissolves in the liquid, we call it soluble. Okay? Pero pag hindi siya na-dissolve, syempre, we call it insoluble. Now, solid and liquid man yan siya. Pag liquid to liquid, pinaghahalo natin, ang tamang term na gagamitin is miscible. Okay? Now, pag naghalo sila class, the term is miscible. The two liquids are miscible. Pero pag hindi sila naghalo, kagaya ng oil and water, we call it immiscible. Okay? Do not use the word soluble if you are referring to the mixture of two or more liquids. So I hope that is clear. Now again, in chemistry, we have this set of rules na ginagamit natin to predict whether a chemical substance can be dissolved in water or not. So especially if the temperature is 25 degrees Celsius. So ito yung mga soluble compounds natin, class. Kapag meron siyang alkali metals, remember the alkali metals are those metals that belong to group 1A in the periodic table. So mga metals so excluding hydrogen. Let's start with lithium. Lithium pababa. Lithium, sodium, potassium, rubidium, cesium. And the polyatomic ion called ammonium, they are all soluble sa tubig. Again, soluble sila sa tubig. So kagaya ng example ko a while ago, sodium chloride. So meron siyang sodium class. So expected talaga yan siya na madedissolve siya sa water. Okay? Even the potassium nitrate, potassium chloride, kapag meron silang alkali metals sa formula nila, automatic they will be soluble sa tubig. Now, aside from our alkali metals, our polyatomic ions like nitrates, so kahit pa i-combine mo siya with other metals like calcium nitrate. So due to the presence of this nitrate, this one will be soluble. Okay? So ang tandaan ninyo, pag tingnan nyo yung formula ng chemical, ng compound, pag merong alkali metal or meron siyang nitrates, acetate, bicarbonate, chlorate, and perchlorate, and meron din siyang halides. So especially itong sodium chloride, no? Sodium is soluble in water. It's an alkali metal. And chloride is a halide. Ang halide yung nasa group 7A ng periodic table natin. Fluorine, chlorine, bromine, iodine, pababa. Soluble din siya sa water. Kaya very soluble talaga ang asin sa tubig, class, sodium chloride. Kasi dalawang component talaga niya ay considered soluble sa water. And then the sulfates also are considered soluble. Silang lahat madedissolve sa water. Meron lang tayong exceptions sa rule natin or sa rules natin. For halides, kapag ang partner ng halides ay silver, mercury, or lead, hindi na siya soluble sa water. So anong ibig sabihin ko dyan? Kapag ang cation ay silver, kahit pa ang kanyang partner ay halide like chloride, so we call it silver chloride, ito class, hindi ito soluble sa tubig. So yan yung exception. Or kung ang kapartner niya ay mercurous or yung positive 1 na mercury, magiging positive 1 yan siya kasi meron siyang subscript na 2. So for example, we have Hg2Cl2 or the mercurous chloride, though meron kang presence dyan ni halide pero ang partner niya kasi ay mercury, so insoluble siya. Yun yung sinasabing exception to the rules. That is also true for lead. So even if you have the halides, but if the partner is lead, insoluble siya sa tubig. Now, that is also true for sulfates, though other compounds containing sulfates are soluble to water. But kapag ang cations nila, ang kasama nila ay either silver, calcium, or for example, calcium sulfate, ayan. Sulfate is supposedly soluble sa water, but since the partner is calcium, it will become insoluble. Okay? That is also true for strontium, barium, mercurous, or the positive 1 na mercury, and the lead. Magiging insoluble si sulfate. That's how we predict class whether a substance or if the reaction will be a precipitation reaction or not. Okay? Now, paano naman yung mga insoluble natin na substances? Again, yung mga insoluble naman, ano ba yung hindi talaga na-dissolve sa water? We have here, class, the carbonates. Please do not be confused. The bicarbonates are soluble in water, but the carbonates are not. The phosphates also, chromates, and the sulfides. Do not forget, sulfides are different from the sulfates. The sulfate is the polyatomic ion SO4, while the sulfide is just the sulfur ion. Okay? Na kaya lang, meron din tayong exception to the rule here. Compounds containing alkali metal ions and the ammonium ion, kahit pa ang partner nila ay carbonates, phosphates, chromates, and sulfides, they will be soluble sa water. So again, pag alkali metal, example, sodium plus the carbonate. So we call it sodium carbonate. So meron kang carbonate dyan, but because its partner is an alkali metal, which is sodium to be specific, this will become soluble in water. Pero kung hindi alkali metal or hindi ammonium yung kanyang partner class, for example, magnesium carbonate, eto, since this is not an alkali metal, tapos carbonate siya, ito yung example ng insoluble sa tubig. Okay? So I hope you will learn this heartily also, so that if you work in the laboratory next time, you will know whether the given substance will dissolve in water or not. So another insoluble compounds are those that contain hydroxides. Again, yung merong hydroxides. Pero may exception pa rin tayo sa rule. Kapag alkali metals ang partner ni hydroxide, alkali metals, yung mga metals na nasa group 1A, and also the barium ion, pag ipapartner natin siya kay hydroxide, magiging soluble siya. All the other hydroxides are insoluble in water. So again, I hope that is clear. Okay? Questions so far? Questions? We have questions here. Let's have an example. I'll give you a compound and tell me whether it will be soluble or insoluble in water? Wait lang. Let me get my list so that I can record the recitation. Okay, Jessica. Hindi mo agi akong ballpen. Okay, let me write on the screen ha and tell me. I'll just give credit to the first three na sasagot. Just write it sa chat. Just send your answer sa chat. Okay, wait lang. Okay, we have here on the screen calcium chloride. My question is, will this be soluble or insoluble in water? What do you think? Yes, yes means soluble siya. No means insoluble. Or you can just answer the word soluble or insoluble. The first three lang tayo ha. Again, the first three sa chat. Okay? Calcium chloride. So if we look at our rules, you cannot see calcium actually there except for this one. Magiging insoluble siya kapag partnered siya sa sulfate. Pero the rest, you cannot see calcium. But chloride is a halide. So asa na belong si halide? Soluble compound. So the answer here is soluble. So that's how you know, class, whether the substance will dissolve in water or not. I hope na klaro to siya. Calcium, pangitao nato si calcium. Kanilang ang time nga nakita nato si calcium sa list, pero mahimo lang na siya insoluble pag ang partner niya kay sulfate. Pero kay dili man ni siya sulfate, chloride man ni siya, and you can see there that halides, including the chloride, is soluble. So again, the answer here is soluble. Madidissolve si calcium chloride sa tubig, class. So sige, the first three na nagsabing soluble will be credited for the recitation sa midterm na ito ha, sa midterm. Remember, recitation or participation accounts for 20% sa inyong grado. So we have, yes, number 1, we have Acosta. And then, yes, we have Arlos. Let me list this guy para na ay justice, no, di ta kalimot kay makalimot ta pag mag-recording na ilabay ang ballpen nga dili mo agi kalagot. Wait, let me choose it first. After kay Arlos, we have Adolfo. Okay, so those 3. Okay. So the rest na nag-answer ng soluble, your answers is correct. Let me give you another one. Another one, you also tell me whether it will be soluble or insoluble sa tubig. Tubig ha, sa water. We are talking about here sa water kasi that is our universal solvent. Let me think first. How do you name this again? We have here magnesium, and then we have here hydroxide. So we call it magnesium hydroxide. The question is this soluble or insoluble in water? Backread first. Ayan. Sige. So let's see. We have here magnesium. First, let's see if magnesium is listed here. We cannot see magnesium. Therefore, we will be referring into the hydroxide. So, hydroxide is here. It is supposedly insoluble, pero let's see the exception. Compounds containing alkali metals, those that belong sa group 1A and the barium ion. But if you look at magnesium, magnesium is under sa group 2A. So it's not included to the rule, therefore it sticks with insoluble. Magnesium hydroxide is insoluble in water. So I hope nakuha ninyo na insoluble siya sa tubig. So the first three here, we have galang. We have galang. And then we have Arlos again. And we have Carriedo. First three lang kayo, daghan kayo. So again, insoluble. But ang iba, tama naman yung sagot nyo. Insoluble. Again, let me clear this one. Insoluble siya ha, kasi you have there the hydroxide. And if you look at the hydroxide, hindi kasali si magnesium sa exception. Okay? You may also add this in your index cards. Marami na tayong index cards class. The first one is for the polyatomic ions. And then number 2, you have the activity series of metal. This one here, you may write this also in an index card. So you will be guided if we are going to make a chemical reaction. Kasi medyo marami. Pag i-memorize nato ni maglibog na ta sa kadaghan. So again, you can place this in an index card also. And for the solubility rules, since medyo marami din ito, tapos may mga exceptions pa tayo, you may also place this in an index card. Okay? Questions so far? Anyone who is confused with the solubility rules ng ating inorganic substances? Inorganic ha, we are talking about compounds without carbon. Meron lang tayong exception. Carbonates and bicarbonates are carbon-containing compounds pero under sila sa inorganic compound. Now, in the laboratory, these are the other examples class. Saan makita yung mga halides? Halides are our group 7A in the periodic table. So please look at the group 7A. In the periodic table, di ba, we call them halogens. We call them halogens. And if they become ions, pag si halogens mahimog ion, meaning na ana siya charge, we call them halides. Okay? So fluorine, chlorine, bromine, iodine. Let's look at the periodic table. So again, since we cannot do the experiment in the laboratory, I'll just give you here an example or examples of reactions that will give you precipitate in the laboratory. But I will just name the precipitate ha. So these are the appearance of the precipitate. Nabuo ito sila after having two liquids na mag-react sila with each other. After the reaction, may solid na substance na ma-form. And these substances or the precipitate may exist in different colors. So just like this one, this is from left to right ha. This one, the orange one, no, the yellow one, colorblind na. The yellow one is the precipitate called cadmium sulfide. Okay, diba remember sulfide are supposedly insoluble. Okay, and then we have again here, sorry, baliktad eh. Yeah, sulfide. Yeah, the sulfide here is under insoluble compound. So mag-produce talaga siya ng precipitate. So cadmium sulfide here. And then the black one is the lead sulfide. Lead and sulfide are both insoluble in water. So as you can see, you have a black colored precipitate there. And then the green one is our nickel hydroxide. Remember, the hydroxide hydroxides are considered insoluble kapag hindi alkali metals or ammonium ang partner nila. And lastly, we still have another hydroxide here, the aluminum hydroxide, but it is color white. So ganito yung magiging appearance nila sa laboratory. Hindi sila madidissolve sa water. It's just nice kasi iba-iba yung color nila sa lab. Kapag gagawa talaga tayo ng face-to-face na laboratory experiment. Okay, so that is for the precipitation reaction. Before tayo mag-move on, sabihin ko lang again para hindi nyo talaga makalimutan. Magiging precipitation reaction lang siya kapag may precipitate ka na ma-form after the reaction. Ano yung tinatawag na precipitate? It's a solid, insoluble, hindi na dissolve na substance formed if you have two liquids na pinag-react. Now, another thing, when you say precipitation reaction, it's under the double displacement reaction. So, ano nga yung double displacement? Exchange partners. Okay? Exchange partners sila. Now, let's move on to the third topic. We have here the acid-base reactions. So, paano naman kung si acid and si base pinag-react natin? Okay? Kasi dito wala tayong acid na example, though meron tayong base. Pero paano kung acid and base ang nag-react? Remember in our previous discussion, if we say acid, they are commonly described as substances that will give you hydrogen ion, especially if you dissolve it in water. Kapag nilagay mo si acid sa tubig and nag-produce siya ng hydrogen ion, H+, we call it an acid. Okay? Again, yeah, there is exchange of one or more hydrogen ions. Now, si base naman, according to Arrhenius, so itong definition na ito ay according sa Swedish chemist na si Svante Arrhenius ha. So Arrhenius theory kasi ito. So ang base daw kapag nilagay mo sa tubig, magbibigay naman siya ng hydroxide ion or OH ion. Now what happen if we make this two react with each other? Before that, let's have a thorough discussion of the two things first, acid muna and then base. And then after that, we'll have the reaction of the two. Now, pag sinabing acid class, aside sa nagbibigay sila ng hydrogen ion if you place them in water, acids have sour taste. So for example, di ba the vinegar, I have told you about this, na pag vinegar, it has acetic acid. Yan yung acid na nasa vinegar. And then lemons and other citrus fruits, mga citrus fruits natin, but if kakainin natin, they also have sour taste, and that is attributed to the presence of citric acid. So yan naman yung acid na nag-exist sa mga citrus fruits. So again, acids have sour taste. And then, acids also cause na magkaroon ng changes in the color of plant dyes. So yung mga coloring substances na nasa plant natin, kapag nagkaroon sila ng reaction with acid, nag-iiba ang color nila. And we can see that when we use the litmus paper. Again, if gagamitin natin yung litmus paper, makikita natin na yes, there will be changes in the plant dyes because the color in the litmus paper actually is coming from a dye. Okay? Coloring substance siya. Kaya kapag dinip mo si litmus paper na color blue, sa acidic substance like sa vinegar, magiging red ang color niya. So that is blue to red. So do not forget, if we are testing whether a substance is acidic or basic, and then if we use the litmus paper, acid siya kapag ka ang blue magiging red. Okay? Or pink to be exact. Now, if you ask me, paano kung pink or red na litmus paper ang gagamitin natin? Then if it stays red or pink, acid yung substance natin, ha? Kung blue, magiging red. Kung red na siya daan, red lang gihapon na siya. That's what we use para ma-determine kung acidic ba ang substance natin or not. Now, another characteristic of our acids is this one. Acids react with certain metals. So, pwede mag-react si acid with our metals such as zinc, magnesium, and iron or other metals pa natin to produce hydrogen gas. So, this will be a form of a single replacement reaction. Again, magiging single replacement reaction siya. We have an example here, the hydrochloric acid. So in aqueous form ha, so liquid na HCl, pag pinag-react mo siya kay magnesium na solid, magkakaroon ng single replacement reaction. Mapapalitan ni magnesium si hydrogen doon sa compound, and then again, you will have the liberation of the hydrogen gas. So kapag ka napalitan ni magnesium si hydrogen, magiging free si hydrogen, but it will be in the form of gas. So as you can see, H2G. G there means it's a gas. Okay? So this is again an example of a single replacement reaction. So that is also true if we react this one, HCl plus zinc. So ang mangyayari, zinc will replace hydrogen. So you have here ZnCl, but you have to check ha, dili class nga mo kalit lang kagbutang og ZnCl din ha, and then that's it. Kasi remember, these are ionic compounds. We have to consider their charges whether we are going to write subscripts or not. And how are we going to do that? Diba? Mag-charge. Tanawon sa nato ang charge. Zinc belongs to the transition metal. So ang charge niyan ay +2 and chloride is -1. So malalaman mo lang na tama ang iyong chemical formula if the sum of the positive and the negative charges is 0. But this time, this is not 0. +2 plus -1 is +1. So we have to do the crisscross, which means the correct formula for zinc chloride is ZnCl2. Okay? So we have again here ZnCl2. Hindi ka basta-bastang nag-exchange partner sila, ma'am. So ang kay ZnCl? No. Kailangan i-check sa ninyo ang charges para tama inyong answer. And then, pinalitan niya si hydrogen. So, remember our bridge, no? Na-mention ko po ni siya last time. Di ba, mauni sila atong mga diatomic molecules. Na kapag hindi sila nakakombine with other elements, they are diatomic, meaning dalawang atoms. So, unsa ganin ni sila? Bromine, iodine, C is for chlorine, H is hydrogen, N is nitrogen, oxygen, and fluorine. So again, diatomic molecule sila. So included dyan si hydrogen, meaning kapag hindi siya nakakombine with other substance, dalawang atom siya. So this is now the reaction. Hydrochloric acid plus zinc will give you zinc chloride plus hydrogen. Pero remember, in chemistry, we always make sure that if we write an equation, it has to be balanced. So balanced ba ito? Di ba hindi? Ano natin malalaman na balanced siya? We'll write this one. We only have 3 elements there. So this one is the reactant na side. This is for the product na side. For the original equation that we have here on the screen, you have 1 hydrogen, 1 chlorine, and 1 zinc. On the other side, we have 1 zinc, 2 chloride, and 2 hydrogen. So definitely this is not a balanced equation. So kailangan natin siya i-balance. So paano nga tayo mag-balance? Siyempre, we will be using coefficients. Yung coefficients, ito yung nilalagay sa tabi ng chemical formula. And that represents the number of molecules present in the reaction. So ano ang ating gagawin? Trial and error. So the first thing I will do is to balance the chlorine. Since nauna naman na siya dito, gagawin ko siyang 2 by placing 2 here sa reactant na side. Okay? So nag-balance na si chlorine. So ang next na lang is, sorry, nanundian ako siya libutang sa zinc. Wait. Pero di siya. Okay. So balance na si chlorine, pero take note na kasama niya si hydrogen dyan kasi isang compound sila. So hydrogen will become 2 also. But as I place 2 here, naging balance din si hydrogen. So this time, this equation is balanced already. Okay? So you need 2 molecules of hydrochloric acid to react with 1 molecule of zinc. No need to place 1 though. Zn na lang siya agad. Ano na yan siya, matic na yan siya na meron siyang isang molecule ni zinc. And pag nag-react sila, this will yield 1 molecule of zinc chloride and 1 molecule of hydrogen gas. Okay? So yan yung magiging reaction ng acid natin sa metals. Magre-release siya ng hydrogen gas. Questions so far? Oras na. Let me look at the time. We'll take a 5-minute break later. Now, let's move on. We have here another characteristic of our acids. Acids can react with carbonates and bicarbonates, kagaya ng calcium carbonate and sodium carbonate, and the product will be a gas again. We have here the carbon dioxide gas. So let's have an example. You have their hydrochloric acid plus calcium carbonate. This will yield calcium chloride plus water plus the carbon dioxide. Now, para dili mo maglibog, actually, ano gihapon ni siya? Double displacement reaction. So you have there the HCl plus the calcium carbonate. So ang original reaction ani class, double displacement, exchange partners. So di ba pag mag-exchange partners, always yan siya positive, i-combine natin siya with the negative. So hanapin mo ngayon saan ang positive, saan ang negative sa first na substance. So di ba it is the hydrogen that is positive and chlorine ang negative. So pag nag-exchange partner sila, hydrogen will be partnered with the negative on the other side. And the negative on the other side is the carbonate. Calcium is positive. So you have there carbonate, and syempre carbon will be partnered now with the Cl. Okay? Pero this is not yet final. Gi-exchange lang nako sila daan. Always remember ha, una isulat si positive na part kesa sa negative. And it doesn't matter whether you write the HCO3 first or the CaCl first. Now, sa kung ginamin nga dili pa ni siya final. Dili pa ni siya final class kasi we have to make sure na tama ato ang chemical formula. Parehas kay HCO3. Baingon ko, i-check sa ninyo ang charge. So, si hydrogen belongs to group 1A. So, this is positive 1. And si carbonate is a polyatomic ion. Can you look at your index cards? Ano yung charge ni carbonate again? Again, can you look at your index cards? Ano yun?
-2.
Okay, negative 2. Wait lang. Ayan, negative 2. Isulat natin. So this is negative 2. So positive 1 plus negative 2 is negative 1. Therefore, we need to do the crisscross. Therefore, the correct chemical formula for the combination of hydrogen and carbonate is H2CO3. H2CO3. And then if we look at calcium chloride, CaCl, calcium belongs to group 2A, so this is positive 2. And chlorine belongs to group 7A, and group 7A ions, ang charge nila ay negative 1. So if we add these two, hindi pa rin tayo makakakuha ng 0. So we need to do the crisscross also. Therefore, the combination of the Ca and the Cl, ang correct chemical formula niya ay CaCl2. This is the original reaction. Supposedly, it's a double displacement reaction. But madali kasing, we call this carbonic acid, madali kasing ma-decompose si carbonic acid class. So ngayon, itong reaction na ito is a combination of the double displacement and the decomposition reaction. So anong nangyari? Nag-decompose si carbonic acid. Pag-decompose niya class, naghiwalay yung mga components niya, and ang naghiwalay dyan is ang water and ang carbon dioxide. So naging ganito yung kanyang equation. So this is also possible. Now this is true if you have an acid reacting with a carbonate or a bicarbonate. Kasi yung magiging product nila always magkakaroon ng carbonic acid, and carbonic acid will decompose always to water and carbon dioxide. So acids, if mag-react with carbonates and bicarbonates, will give you a carbon dioxide gas. So pinakita ko lang sa inyo ano ang nangyari. Bakit nagkaroon ng carbon dioxide. And lastly, we have here acids class. The aqueous acids, kapag in aqueous solution sila, they will conduct electricity. So acids are considered as electrolytes because if we place them in water, they will ionize, magkakaroon ng ions, and that is the reason why mag-conduct sila ng electricity. So that is for the acids. Okay? Now, let's talk about the bases. If the acids are sour, the bases naman have bitter taste. So, ato ang mga bases, again, have bitter taste. They feel slippery. For example, ang ato ang sabon. So, kinsay nakatry na din magbuhat og sabon? Pang high school, wala pa. If we will have face-to-face food na laboratory class in your I think biochemistry, if I'm not mistaken, you will be taught paano magbuhat og sabon. So ginahimo nato na siya sa laboratory. Sa lab kasi pag magbuhat ka og sabon, it's just a combination of a basic substance. Most of the time it's sodium hydroxide or potassium hydroxide, and pinapa-react natin siya either with a fat or an oil. So parehas anang palmolive. Itawag na siya palmolive class kasi it's a combination of the palm oil and the olive oil, tapos pina-react with either sodium hydroxide or potassium hydroxide. So again, mao na siya gitawag siyang palmolive. So definitely sabon man, it feels slippery. Mao na siya ang isa ka property sa ato ang basic substances. And then, just like the acids, bases can also cause changes in the color of our plant dyes. So, kagaya ng litmus paper. Kaya lang, baliktad sila. Si acid class, if i-dip mo ang blue litmus paper, magiging red siya or pink. Pero pag base siya, basic substance siya, the litmus paper na red will turn to blue. Mahimo siya og blue for the litmus test. And just like the acids, bases also conduct electricity. Because if you mix bases or if you place a base in a water, it will also ionize. Magbibigay din siya ng substances na may charge or na may charges, kaya again magkakandak siya ng electricity. So yun yung mga significant natin na characteristics ng ating bases. Do you have questions or clarifications sa acids and bases natin? So yung definition ng acids and bases natin na may hydrogen and may OH, it was given by Arrhenius. Kaya lang, meron din tayong tinatawag na Bronsted acids and bases. Itong Bronsted acids and bases, this was named by Johann Bronsted. Siya yung nagbigay. Sa kanya din pinangalan yan kasi he gave a broader definition para sa acids and bases natin. Hindi kasi lahat ng acid magbibigay ng hydrogen, hindi din lahat ng base merong hydroxide. So ngayon, yung mga hindi nag-fit in doon sa definition ni Arrhenius, pwedeng mag-fit in dito sa definition ni Johann Bronsted. So according to him, tatawagin natin siyang Bronsted acid kapag siya ay proton donor. Again, nagdo-donate siya ng proton. And Bronsted base siya kapag kaya niyang mag-accept ng proton. Yun yung definition ni Bronsted sa acids and bases. And unlike kay Arrhenius, si Arrhenius kasi kailangan nasa water, di ba? Kailangan in aqueous solution si acids and base para makita natin na nagbigay talaga siya ng hydrogen or nag-give off talaga siya ng hydroxide. This time for Bronsted, it is not necessary for the acids and the bases to be in aqueous solution. Ang tandaan lang natin, pag proton donor siya, acid. Pag proton acceptor, it's a base. Pero pwedeng mag-overlap ang dalawang definition na ito, kagaya ni HCl. HCl is an Arrhenius acid because it has hydrogen. But it can also be considered as a Bronsted acid because it has also the ability to donate proton. So anong mangyayari? We have here, let me get my pen first. We have here hydrochloric acid. So it's an Arrhenius acid because again, it will give you the hydrogen. Pero again, it can also be a Bronsted acid. Bakit? Si HCl, kapag pinag-react natin siya sa water, ang gagawin niya, class, idodonate niya yung hydrogen na yan. Therefore, the proton is most likely referring to the hydrogen ion pa rin. Again, the proton is still referring to the hydrogen ion. So as you can see on the screen, hydrochloric acid will donate this proton or this hydrogen to water. That is why the resulting products will be this one, H3O+, diba H2O, since nadugangan man siya isa ka hydrogen, nahimo siya H3O+. Nagkaroon siya og charge. We call this H3O+ as hydronium ion. Okay? H3O+ is called the hydronium ion, and since gidonate niya ang proton, then it will be left with a Cl. So in this equation, it reveals that HCl is a Bronsted acid. It has the ability to donate the proton, and most likely the water there is considered a base. So si water can also be a base. Nga naman, siya may nidawat sa proton. Siya ang nag-receive, nag-accept sa proton. So it can be considered as the Bronsted base. So yan yung definition, class, ni Bronsted for acids and bases. Donation and acceptance of proton. Pero by the way, let me correct this one also and give emphasis to this. When you say water, water is an amphoteric substance. take note of the word amphoteric. Anong ibig sabihin yan? It can act as either acid or base. So that's the uniqueness of water. Again, that's the uniqueness of water. Pwede siya acid, pwede po siya base. So in this case, since siya ang nag-receive sa proton, water is a base. Pero there are some cases that water can also be acid. Okay? So again, water, ang tawag na to anak, kung pwede siya acid, pwede siya base, kay amphoteric. Amphoteric substance. Yan. You ask question if meron kayong hindi naintindihan. Now, I'll just give you examples of acids commonly used in the laboratory. So most of them, as you can see, naasilay hydrogen. And if we are going to have a reaction with a base, they can also donate protons or the hydrogen itself. So we have hydrochloric acid mo na pero may ginaulit-ulit nato. Again, HCl, the common name for that is the muriatic acid. That's what we use, like for example, in cleaning our, what do you call that? CR. And then that is also our gastric juice. Now we also have nitric acid, which is very used in the laboratory, pero it's a strong one, so di niyo na siya pwede gamiton with your bare hand. And then acetic acid, which is found in vinegar. Sulfuric acid also is very much used in the laboratory, and also phosphoric acid. Okay? And then the first three, hydrochloric, nitric, and acidic are called, acetic. The first three class are called monoprotic acid. Nganong gitawag silang monoprotic acid? Because they have one hydrogen only, and they can donate one hydrogen. They can donate one proton only. Just like this one, HCl may give off one hydrogen only. So mo na siya gitawag og monoprotic, proton, that is referring to hydrogen. HNO3 is also monoprotic. And as you can see, acetic acid do na kay hydrogen din nga tatlo, pero in the reaction kasi kaya weak acid si acetic acid kasi isa lang talaga ang pwede niyang mabigay na hydrogen. Itong tatlo na ito, hindi niya ito kayang ibigay. But nevertheless, monoprotic pa rin siya kasi again, isa lang ang kaya niyang i-release or i-produce na hydrogen. So again, the first three, hydrochloric, nitric, and acetic. Now, we have here some common, strong, and weak acids. The strength class will be determined sa pH, and it will be determined by their ionization. If there is complete ionization, lahat ng components ay magiging ion, magkakaroon ng charge, it will be considered a strong acid. But if not, the pH is medyo taas and hindi siya mag-ionize completely, ang tawag natin dyan, weak acid. By the way, before that, we have the pH scale the pH scale natin. So we have 7, ang pinakababa ay 1, ang pinakataas ay 14. If the pH is 7, then we call it neutral. It's not acidic, it's not basic, it's neutral. But pababa, 7 to 1, pababa, the substance will be an acid. Okay, just like sa atong stomach. Example, ang pH sa atong stomach ay 2. So, ang atong stomach syempre is acidic. But pag maglampas siya ng 7, pinakataas 14, the substance is basic. That's how we interpret the pH scale. So, I hope walay ma-confuse ana kay usahay mabaliktad. So again, we have here the strong acids, and most of them, mostly they are inorganic acids, so they don't contain carbon in their structure. So we have here hydrochloric, hydrobromic, hydroiodic, nitric, sulfuric, and perchloric acid. And we have here the weak acids, hydrofluoric acid, nitrous acid, phosphoric acid, and lastly, the acetic acid. Actually, included din sa weak acid si oxalic acid. I believe you are familiar with oxalic acid. It's a weak acid. Okay? And then, yung sulfuric acid class is considered diprotic acid. Itong tatlo kagaina, hydrochloric acid, acetic acid, nitric acid, monoprotic, kay isa lang na hydrogen. Pero si sulfuric class, actually, it can give up 2 hydrogen ion. And that is why it is called diprotic. So, di ba, the original chemical formula for sulfuric acid is H2SO4. So, the first round of the reaction, it will give off 1 hydrogen, and then you'll have the ion here, HSO4, or the hydrogen sulfate. And then, further ionization of the hydrogen sulfate will give you another hydrogen. So, dalawang hydrogen na yon, and then you will be left with a sulfate ion. So again, since dalawa, we call it diprotic. And syempre, si phosphoric acid is a triprotic acid because it can yield or it can produce 3 hydrogen ions. So by step yung pag-release class ng hydrogens na yan. You have here the original H3PO4. First round of ionization will give you 1 hydrogen and you will be left with the dihydrogen phosphate. And then further ionization of the dihydrogen phosphate will again give you hydrogen ion, and you have here the hydrogen phosphate. And then itong hydrogen phosphate na ito, mag-ionize na naman, magbibigay na naman ng isang hydrogen, and then the last one here is the phosphate ion. So all in all, you have 3 hydrogens na na-produce galing kay phosphoric acid. Kaya tinatawag siyang triprotic acid. Okay? Questions so far about this one? Wala. So let's move on. We'll have the bases. Again, according to Arrhenius, the chemist Arrhenius, bases yields hydroxide ions. So that is why we have examples on the screen. We have an AOH, the sodium hydroxide, and the calcium hydroxide. Pag hindi po pala siya isahan pagbigay po ng hydrogen, ma'am. Example po. No, so during sa ionization, it's step by step. Pero nevertheless, the reaction is actually fast. The rate of the reaction is fast. So definitely, mag-ionize na gid na siya hurot tanan. Dili lang siya pang-isahan. Okay? Step by step tayo. Mag-release siya isa-isa og hydrogen. Again, we have sodium hydroxide and barium hydroxide here. And these are strong bases. So definitely, they are also considered as strong electrolytes. Pag strong acid o strong base, strong electrolytes po sila, ha? So meaning ana, kung strong electrolytes sila, meaning they will be completely ionized in water. So just like sodium hydroxide, the solid one, if you place that in water, it will ionize to sodium and also the hydroxide ion. It's complete ionization. All the molecules, all the components will ionize. Barium hydroxide also will give you barium and the hydroxide ion. So the OH ion can accept a proton as follows. So itong hydroxide na ito, pwede siya mag-accept ng proton and then magiging water siya. Now since the OH class has the ability to accept protons, like this one, the hydrogen, so OH class is also considered a Bronsted base. So mag-fit in siya sa definition ni Arrhenius, mag-fit in din siya sa definition ni Bronsted. So basic talaga kapag ka merong presence ni OH. So another example of a Bronsted base is ammonia. So as you can see, according to Arrhenius, dapat may OH ang base. Pero si ammonia is a basic substance pero wala siyang OH. Pero anong nangyari dyan? Bakit siya considered as a base? Kasi si ammonia class has the ability to accept proton. So example, if you place ammonia in water, ang isang hydrogen ni water will be transferred to ammonia and it will become ammonium. We call this NH4 as ammonium. And water will be OH na lang kasi binigay niya na si hydrogen. So again, ang definition ni Bronsted base, kaya niyang mag-accept ng electron. Ay, sorry. Anong electron akong gisulat? Proton. Ayan. It can accept proton. And we are referring to hydrogen as the proton. Naging NH4 na siya. So, naging positively charged siya. So, even though si ammonia walang OH, Bronsted base pa rin siya. So the most commonly used strong base in the laboratory is actually the sodium hydroxide. Actually, if we want to produce a hard soap ha, dili ka ng detergent bar, soap ka nang ginagamit na to magligo nga hard soap. Kagaya sa Safeguard. Ang ginagamit na to ana to produce that one is the sodium hydroxide. Pero if gusto ta og liquid soap, kaya mga ginagamit na to like mag-hand wash ta, most of the time ang ginagamit ana is potassium hydroxide. So kana sila ng mga bases, ginapareact na sila with either fats or oil. So parehas anang lard, kanang animal lard, kanang fat bitaw sa baboy or sa baka, pagbutangan nimo na siya og either sodium hydroxide or potassium hydroxide, mag-form na siya into sabon. So, pero ang ginagamit sa lab, sodium hydroxide. It's actually cheap and at the same time, soluble. So, actually, lahat ng alkali metal hydroxides are soluble. Alkali metal had the group 1A, lithium, sodium, potassium, and so on. And that is for the strong base. But for the weak base, ang ginagamit nato is the ammonia. No, ang pinakaginagamit na weak base. The aqueous ammonia solution, but actually sometimes ginatawag siya ammonium hydroxide, pero actually it's erroneous kasi ammonia lang yun siya. Ammonia is NH3. Again, ammonia is NH3. Ammonium hydroxide is NH4OH. So that's two different compounds. Dili na to sila pwede i-interchange. Now, all of the group 2A elements form hydroxides of the type MOH2, where M denotes the alkaline earth metal, and yung syempre yung OH, since magiging 2 siya kasi di ba ang charge ng group 2A elements ay positive 2. So nagka-criss-cross tayo. So of this, only the barium hydroxide ang soluble. Nakita naman natin yan kanina sa table natin ng solubility. And then magnesium and calcium hydroxides are used in medicine and industry. Parehas anang nagainom ba mo og Kremil S, Simeco, Maalox. Those contain hydroxides, especially aluminum hydroxide and calcium hydroxide. So ginagamit siya in the pharmaceutical na field. But aluminum hydroxide and zinc hydroxide are insoluble and are not used as bases. Kana lang silang duha, wala sila ginagamit as bases kay dili sila soluble. So it's 8:55. We will continue tomorrow with the acid-base neutralization, the reaction between the two. And then we will also discuss the oxidation reduction reactions. I hope we can finish that by tomorrow. So since it's 8:56, dinha lang sa ko mag-end. Do you have questions, class? Or clarifications about the things we discussed this morning? Wala pa tayo quiz tomorrow, ha? I don't give quiz ka ng sa tawag ana, wala pa na ako nahuman ang lesson. Next week, mag-expect mo nga next week, mag-quiz na ta. Okay?